Hello everyone, and thank you very much for joining me again for lesson 12 of the Spring Security Fundamentals stream. And we are discussing about the grant types after in the previous lesson we've started with the OAuth 2 chapter. And this is a really important chapter to deal with because it's quite used today in applications and especially in cloud applications, as you probably know, and as we've also mentioned in the previous lesson. And if you're watching the event live, don't forget that you have a live chat there, so you can ask me the questions directly in the live chat. If you are watching the event recorded, you can still ask questions in the comment section below, or you can find me on LinkedIn or Twitter and you can ask me questions there as well, and I will either answer you in a new lesson in a future lesson or in a new video depending on your questions. So now I will continue what we've started with in the previous lesson, in lesson 11, and you do remember, maybe if you've been here with me or if you have watched the video record of the previous lesson, that we've implemented or we've started at least the implementation of an authorization server, and now we are going to discuss deeper details about the grant types, and they are really important because no matter which is the implementation of authorization server that you will use in your system, you might use not an authorization server developed by yourself, but you might use some third party, and it can be a tool like Keycloak, Okta, it can be Cognito, it can be some other thing, it can be the new implementation of the authorization server from Spring Security. It doesn't matter which is your implementation of authorization server you are using, it's still the grant types that are described clearly in the specifications that will be the same for all of them. So that's why it's really important you understand these grant types, and we discuss here about the most common grant types in the past lesson. I've already proved how the password grant type works, and then we've ended with the authorization code, but we were quite in a hurry on the end of the lesson. So now I will take them, and for all the grant types I will create a sequence diagram, and of course we will also test them in our application. So what I've done here, I still have my IntelliJ, and this is simply a copy of the project from lesson 11. So you see I've copied it. You can even see here it remained 11. It's simply a copy paste, and it's precisely the way we've left it in lesson 11, and I will continue from the same implementation so that we don't lose time recreating the same thing that you already know and you've already seen me developing in the previous lesson. We will start from where we were, but I will retest and I will create a nice detailed sequence diagram for all of the grant types that we discuss. And by that I want to be pretty sure that you understand which are the grant types and how each of them works, and that will help you further in our discussion when we go to the implementation of the resource server. And of course, if we finish today discussing the authorization code, password grant type, and client credentials, we will also go into a deeper discussion about the tokens, because that's the next main topic of the chapter. And then the next thing we'll have to deal with probably in the next lesson is the resource server and the connection between the resource server and the authorization server. So I'm going back to my tool I'm using here for creating diagrams, and you can see I've prepared already again the four roles we discussed about in an OAuth 2 system. They are the user, the client, the authorization server, and the resource server, and we've started with them also in the last lesson, and I hope now that is clear for you which is the purpose for each of these roles. But what I will do now, I'll actually create a different diagram, and I will basically create a different diagram for all of the grant types, and that will be a sequence diagram. So I will try to do something like this. I will try to simply put a timeline here for each of the roles, and we'll discuss about their interaction in the grant type, and then we will test together with that each of the grant types. So let's start with the simplest grant type, which deals with users. and that's the password grant type. So remember we discussed about the password grant type. Mainly I've said that you shouldn't, I put here deprecated in the last lesson near the password grant type, and I said you should avoid it, and generally you should use the authorization code grant type instead. But there are still applications, and I've seen a lot of applications using the password grant type still, and I don't consider that's really bad idea sometimes to use the password grant type. And also in our examples, using the password grant type will enable us create tokens faster. So sometimes we will use the password grant type not because it's necessary what we want to prove, but because it's the easiest way to generate tokens. Because remember, in OAuth 2 mainly everything's about getting a token, an access token that the client then uses to access resources on behalf of a user. So yeah, going back, let's see how is this actually password grant type, how does it work, and then review the steps for the password grant type we've also worked on in the previous lesson. But I hope with the means of the diagram it will be much more clear the interaction between these. So let's see what happens. Basically, first step is that the user tries to do something on the client. The client is simply an application. It can be a mobile application or it can be a web application. Usually when we discuss about web here, we discuss about applications created with a framework like Angular or React or Vue. It's not that kind of a web application where the response is completely provided by the server side and the client only interprets the response. You know that in case of using, for example, a framework like Angular, it's usually a one-page application that represents an application running in the browser and usually collaborating with the backend side via REST endpoints. So this is mainly the kind of application in which you'll see in case of an OAuth 2 system as a client, or it can be again a mobile application like an application running on your Android or iOS device or something else. So first of all is the user trying to do something, and then when the user tries to do something, of course the client needs some data. It either needs to get some data or it might need to modify some data, and that's on the backend side, which, by the way, remember, in case of OAuth 2, the backend of the application is this resource server, we call it. So this is basically the backend of the application. The authorization server is just a responsibility we decouple from our backend, which deals with authenticating the user and offering the client an access token that the client can use to get the resources, to get access to the resources on the resource server. And as you will see when we go into more details with developing both of them, they can even be sometimes only one application, so they are two different roles, and they are usually in most of the systems they are different applications. Like this is a Keycloak and this is your application, or this is your authorization server customly developed by you, and this is your resource server, which is the backend of your application, the backend that you are basically protecting. That's the resource server. So the client actually needs to get to the resource server to access the data somehow, the data needed for the action requested by the user. So what does the client do? It can't simply go to the resource server and ask for the resource, because simply making a request against the resource server will be rejected if it doesn't, if the request isn't accompanied by a token, by a valid access token that allows the client to access that resource. To obtain a token, the client needs to get to the authorization server and get a token issued by the authorization server. When we have the client grant, we have the password grant type, we rely on the user's credentials to be sent to the client. So here we have the username and the password, and this username and password, they are known by the client and they will be sent further by the client to the authorization server, and then the authorization server, oops, that's not what I wanted to do probably. The authorization server validates the username and the password because the authorization server knows the users, and will of course get back with a token, will issue a token back to the client in case the credentials are valid. So the authorization server goes back and provides the client a valid token. So this is a access token going back. And now that the client has an access token, it can make the request to the resource server providing that access token, and the resource server will return or will simply do whatever the action means. It might be change data, it might be return some data, it might be something else with the user's data. We don't care about that. Anyway, in order for this request to work, the client needs the access token. So the client gets the username and password from the user, sends the username and password to the authorization server, assuming they are valid, gets back a valid access token, and then sends the access token to the resource server, and then the resource server authorizes the client to do something with the user's data. So this is the password grant type. This is what we call the password grant type. Of course, there's still an unanswered question here, which is how does the resource server know that the token is indeed the one issued by the authorization server? But we will take this later in probably the next lesson when we discuss about the resource server, and you will see that's not only one way to do that. There are actually about three main ways in which the resource server can validate the access token, and that's either using token introspection or using blackboarding or using cryptographic signatures, and that's where that JSON Web Token everybody might have heard about is used, and one of the probably main used methods for this. But we will discuss this all these three in detail in the next lessons. So important for now is you understand very well each of the flows. Should we now try to repeat this flow in our application? Let's do that. Let's make sure step by step this is precisely the way it works. So let's make sure this diagram is valid and it proves the way the password grant type works. For that, I will go back to the authorization server we have developed in lesson 11. And you will see it's precisely the same one. I didn't change anything. I have used the current way of creating the authorization server. Remember, the Spring Security team started working on a new server, but that will probably be mature 1 year from now on. So we still work with what we have, which is the current implementation. And we have a couple of clients registered here. Client 1, which has the password grant type assigned, client 2, which has the authorization code. So this is where we left it in the last lesson, and we need something more. We need, of course, to have at least a user, and we have at least a user. Will you take on also the OpenID? Hello again, thank you for the question. So OpenID. What is OpenID Connect? If this is the question I've got in the chat, and if we will work on it. Well, first of all, what's OpenID Connect? OpenID Connect is a protocol that is above OAuth 2. So in order to discuss about the OpenID Connect, you first need to understand the basics of OAuth 2. So you need to know what OAuth 2 is. Because what OAuth 2 is actually, it is a framework that generally specifies ways in which the client gets access tokens, and then using the access tokens, it can get resources that are exposed by your backend application, which we call the resource server. But OAuth 2 doesn't impose too many limits. So it doesn't tell us how the token should look like. It doesn't tell us how the endpoints should look like. It doesn't tell us which are the scopes that we can use. I basically could use anything. So I've simply my scope is named read, and I could have named it ABCDE. okay? Because I have no restrictions. I'm using opaque tokens, they are called those UUIDs, because I have no restrictions, because OAuth 2 doesn't impose any restriction. It's simply a specification and I build above it. And having no restrictions is great, but sometimes it imposes some difficulties. Like what happens if we have an authorization server that is not managed by us. For example, what happens if we try to use GitHub as our authorization server? Well, we can read the specification and we can see how the scopes look like for GitHub, and we can work with it. But wouldn't it be better if we had some constraints above OAuth 2? Wouldn't it be better if we had some defined scopes, some clear endpoints, how they should look like, something like this, some restrictions imposed over the framework so that we know precisely what to call and how to call? Well, this is OpenID Connect. OpenID Connect is nothing more than a protocol above OAuth 2 that imposes some restrictions over OAuth 2, which is very, very free. You can do everything over OAuth 2. Then imposing some restrictions allows us sometimes to know better how to call an authorization server and how to work. So OpenID Connect is a protocol that is designed above the OAuth 2 specification. So that's why we first discuss the OAuth 2, and then we will discuss about the restrictions of OpenID Connect. But basically, if you understand what OAuth 2 is, OpenID Connect is nothing more than understanding some restrictions, some more specifications regarding the scopes and the endpoints above OAuth 2. So I hope this answers the question, and yes, we will work with it, especially when we'll do a single sign-on application, because there is basically where we'll actually have to work with OpenID Connect. We'll do an example with GitHub, and that's how we'll have to work with. But until then, I hope that at least clarifies what OpenID Connect is and what's the relationship between OpenID Connect and OAuth 2. Now let's go back and try to call and prove our password grant type here. So I've started. No, I didn't start. I will start it now. My authorization server. I have the two clients I have registered. Each of the client has only one authorization grant type, and then I have also one user I can work with. And the first thing I need to do is prove how okay, so I have something here. We don't care, let's close it completely and take it from 0. Okay, so we want to get a token. What happens is this is my client, and I, as a user, I'm trying to call some endpoint on the resource server. Of course, we don't have a resource server now, but we can get at least in the diagram to the point where we get back the access token, because then we know that the access token will be used to access the resource in the resource server. So let's see how can we get the token that we know we could use further to obtain the resource. Could we do that? Yes, we can. We go back to our postman, and I need to provide as a user the username and password to the client. The client is mocked here by my postman, and the postman will use my username and password, which is John and 12345, send them to the authorization server, and then we directly get back an access token. So this is how we expect it to work. And I do that localhost 8080 OAuth 2. OAuth actually is the endpoint token, and then I have to specify which is the grant type that I use. So I use the password grant type, and I have the username John, and I have the password 12345, and I need a specific scope. I have to also provide the scope that I request. The scope the scope can sometimes be even used in the authorization rules, but we will get to that when we deal with the resource server. And yes, we also need to use the client credentials to authenticate. So remember, here is client 1 in my case, and I do send it, and I get back an access token, which is a plain UUID. It's only a plain UUID. This is what we call an opaque token. It's a token that doesn't contain details about anything. It's simply just a string, and it's mostly like a password. And we'll learn that to get details about an opaque token, we have to do some token introspection, which is actually calling an endpoint on the authorization server. But this token is the access token that a client can now use to access resources on the resource server itself. So we actually got to this point, and the only thing I missed on this diagram was the fact that the client needs also to authenticate. So that's client and it's secret. So this is also needed. The client itself needs to authenticate, and of course the authorization server only accepts a request from the client it knows. So it won't accept a request if the set of credentials, if this client isn't known by my current authorization server. This is why I needed to register the client. And remember, we discussed in the previous lesson that we registered it in memory, but you know that you can actually implement a way in which your clients might be taken from a database. We discussed this in the previous lesson. Okay. So we've proved the password grant type, and you know now the entire flow, and you know all the details about it. Now can we copy paste it? Let's copy paste this and do the same for, okay, I will do like this, and do the same for the authorization code. Let's see if I can do the same diagram for the authorization code, which is a little bit more complex. So let's see what happens in case of the authorization code. I will clear it out, and then I will take it from 0 on the timeline with my 4 actors here. So one of them will be, first, yeah, of course, the user tries to access a functionality that is implemented by the client. So like in the case of any situation, we start by user trying to do something with the application. That's always the fact. And then what happens is that the user doesn't share anymore the username and the password in this case. So it simply uses it simply needs to authenticate directly on the authorization server. So what happens here is that the client says, okay, I need a token because I can't access the resource here if I don't have a token. So how can I get a token? Well, I ask the user to go to the authorization server and authenticate. So I redirect the user to a page on the authorization server so that the user can access and get authenticated by the authorization server. So this is a very, very big difference. You see here, I don't have the username and the password anymore shared with the client. I have the username and the password, however, shared with the authorization server. But that's clearly better because in this case, in the case of the password grant type, so I can name it here, it's password grant type. In the case of the password grant type, the user, the client, and the authorization server, all three, they know the user credentials. So if the client and the authorization server are not developed by the same organization, or how I like to call it, if they are not part of the same system, then the authorization server can't actually trust the client to allow them to get the username and the password. And even if they are part of the same system and developed by the same organization, it's still sometimes risky to allow the client manipulate the username and the password because they are easier to be stolen if we do so. So that's why usually we avoid to use the password grant type. Well, in the case of the authorization code grant type, this gets solved because now the client doesn't know anymore the username and the password of the user. So when the user tries to access a functionality, then the client redirects the user to the authorization server. They access probably a form, and in this form then they authenticate. Assuming the username and the password are valid, then the authorization code, the authorization server will send back the client what is called an authorization code. So this is the authorization code, which is not the access token. If the authorization server would have directly provided back the access token to the client, we said we are in the implicit grant type. But the implicit grant type is deprecated and we don't use it anymore. When this implicit grant type was actually enhanced to use the an authorization code to eliminate the vulnerability of sending directly the access token to the client, which potentially could have been redirect to URI, which was not the client. So now it sends the authorization code, and then the client will use this authorization code back to the server and will get back only in this step will get back the access token. So username path, and then it gets the authorization code, sends back the authorization code in a request, and then it gets the access token. And the access token is the end of the flow again, because now the access token is what the client can use to call the resource server. So now we call the resource server, and then, yeah, of course, in this case it will work because we have provided a valid access token. So a little bit more complex, as you can see, the authorization code grant type, it has some more steps, but is the way you would choose to implement basically in your real world scenarios most of the times, because it avoids the share of credentials between the user and the client. So as you can see, the credentials of the user are only known by the authorization server, which only anyway knew them, and the user, which anyway knew them. So you avoid sharing them with somebody else, which is more secure. So can we actually, again, can we take it step by step on the diagram and see how can we get the access token, so get to this step in our implementation? And the answer is yes, we can do that. I have already started the application when I've tested the password grant type, and now I can do the same flow, but I will use the second client, which enables me using the authorization code grant type. So let's use the authorization code grant type and see if this works precisely as I've drawn it in my diagram. So I have to first go to a browser. I have a browser here. I will just grab a tab so that you can see it. And the first thing I need to do is to access the user, the page to login. I need to access the page to login in the authorization server. Well, imagine I don't have a client now, but if I had a client, then the client would have been the one to redirect me to this page that I will access now, which is known as the authorization endpoint, the authorized endpoint actually. So it's OAuth to authorize. Let's call it just OAuth because it seems I have a bad hand today. Okay, so I'm go to the authorized endpoint, and then I have to authenticate myself. I will be redirected to login, and then when I log in correctly as a user, I get authenticated, and then the client is called back on the redirect URI, and the OAuth code, the authorization code, is provided. So this is the first step. Let's see if I can do that. So I'm going here. and my authorization server is on port 8080. Then I have OAuth 2 authorize. And then let's see what I need to say here. Is kind of this remained from our previous lesson, from lesson 11 in my browser here, in the history of my browser. So, but I will repeat what I've added here. So this is the endpoint to where the client would redirect me, and then the first parameter you see here is the response type code. This enables the authorization server to know that I want to do this with the authorization code flow, because my alternative would be to do the implicit flow. So instead of code there, I could just say implicit, and if I do that, I will get back directly the access token, but that's not my choice. And anyway, my client is registered for the authorization code, so I couldn't do that anyway here. I specify that I want to access and to get back the response as an authorization code. And then I say who is the client, because remember, the client is redirecting me here. So the client knows its ID and will add the ID here. In my case is client 2. And then of course here as well, I need to provide the scope. And so here, again, back on my diagram, I'm redirected here, and then the client, when it redirects me to the OAuth, forces me to call this, it will be OAuth that will contain as parameters the response type code, so that the authorization server knows I want an authorization code, and then the ID of the client, so that the authorization code validates that this is a known client and allows me to obtain it. And then of course the scope that is somehow as the domain of the client, and again you will see we can use it in authorization rules when we get to that. So that's why I needed to put all this. So now I will just press enter, and I'm redirected to a login. The authorization server expects me to log in as a user, so I, as a user here, will insert my username and password, which is John and 12345, which is the only user I have in my authorization server now. So I'm going here and I say, okay, I'm John, and this is my password. And when this is correct, I press the sign in. I need also to approve once more, and then I get redirected back to the client. You see here localhost 1990. This came from my configuration here. I had to specify in my configuration which is the redirect URI. So which is the URI the authorization server should redirect to when the authentication completes. And that's why you see this URI, which in general you should have in my application. I have no client here, so that's why it's not working in the browser. You don't see anything because I didn't implement it. But you can clearly see that indeed the authorization server did the correct thing and indeed redirected me to this page. And more than that, the most important thing is that it provided me a valid authorization code. So it's precisely this step here when I've authenticated, and then because I've authenticated correctly, I was called back on the redirect URI, and the authorization server provided me the authorization code. And that's why this grant type is called the authorization code grant type. So now I can use this authorization code to call the same token endpoint you've previously seen me calling with the password grant type to get back an access token, because the end of the flow is when I get back the access token. When I get back the access token, it's when I finish with this. So let's go back to Postman, and I'm again doing a post. It's basically the same endpoint here, but a few things will change, and that's the username. I don't need it. The password, I don't need it. Not that I don't need, but I don't know it, I can say. And then the grant type is authorization code. And then more than this, I need to provide the code. So the code, the value of the code, which is the one I've received back here. So I copy this, and when I press send, Oh, I do need to authorize, sorry. I do need to use a basic authentication, and this is client 2. Okay, so the client still has to authenticate, of course, to call the endpoint. And yes, I got my access token. And remember, I can do that with the authorization code that I've got only once. So if I try to do this now again, it won't work anymore. It's an invalid one because this one was already used. I can use one authorization code only once. And now let's go, and of course this is the end, because I've proved how the authorization code grant type can be used to get an access token, and this is the access token the client can now use to access the resource on behalf of the user. And now we go to the third grant type, and the third grant type is actually the client credentials. And the client credentials is a special grant type itself because it's not related to the user. So that's one very big difference, is that this actor completely disappears from here. So that's why it's called client credentials, because the client only uses its own credentials to get the access token in this case. So the client credentials is a grant type where the access token is obtained, but not on behalf of the user. It's only obtained by the client. And when do we use such a grant type? When do we have such a grant type where we don't need to have a user? Well, assume that your application has an endpoint that's called to make sure that the application is still alive. We usually see this with deployments nowadays, especially with deployments orchestrated in containers. For example, if you deploy your application within a Kubernetes cluster, you'd like to have liveness probe implemented for your application so that Kubernetes can test that your application is still alive. Well, in this case, that endpoint that tests that your application is still alive, for a readiness probe that's ready, and it can be coupled to a load balancer. In case of Kubernetes, this is how it works. That's not related to any user. The fact that you have an endpoint there telling some details about your application, it's not user details, it's not user resources. So in this case, you need somehow to be able to call an endpoint, but you don't have a user, and you don't need a user because you don't access user details. We will for sure have videos about testing. Thank you for the question. So yes, testing with Spring Security in this stream, but I will also do some separate stream on testing itself later. Thank you for the suggestion. Yes, so now going back, that's why we need the client credentials grant type. We need the client credentials grant type because there are situations in which we need to be authorized to access an endpoint, but that endpoint is not a user resource. And in this case, this is the simplest grant type. The only thing that happens here is that the client requests only sends its credentials. So these are the client and the secret, client and secret. Assuming they are valid, it gets back an access token. So this is the access token back. And then of course the client can use the access token to call the resource, the endpoint. So assuming the client is your orchestration tool, the client is your Kubernetes, we'll need to get somehow the access token, and then we'll be able to call the endpoint it uses to test the readiness or the liveness of your application, which is something again that you'll see always implemented in such a deployment. So that's the client credentials grant type, when we have no user and we only need a client. So let's see if we can also use this grant type. But to use this grant type, of course, I need a client, and you see I have no client here that allows me to use the client grant type. So I will actually have to add one more client. So let's add one more client. How do I do that? Well, pretty easy. Should be an end here, and then I copy pasted client 1, but I will change it. So I have client 3, secret 3, and then the scope is not really important for the moment, but of course here I need to do it client credentials. So client credentials grant type, this is what I need to use basically. So I do restart my application, that's everything. I've only added a new client for which the authorization server allows me the client credentials. I should now be able to test it. So let's test it and see if it works. So my application started, and now I have another tab, and I'm still using the same token endpoint, but of course with different parameters here. I need a grant type, but the grant type is now client credentials, and I only need to specify the scope. Because the client ID and the client secret will automatically go through the HTTP basic when I'm authenticating. So here it should be 3 and again 3 to be correct. And then when I send, then it says method not allowed because yeah, it should be a post, of course. And yes, I get back the token. So you see, this is the situation in which I can get an access token without the user. I will tell you later why you should be very careful with this grant type and which are some main mistakes you could do when using the client credentials grant type. And one of the main mistakes I've seen is having a client which can do also the client grant type but can also do the authorization code or the password grant type, and it offers access to the same scope, like read in this case, which is a very bad choice in your design. But again, we will discuss this in details later when discussing the authorization part. But now, with this being said, well, you've actually seen the 3 most important grant types you will use with your OAuth 2 systems. And the next and the last grant type I discussed with you now, and that makes 4 of them, we'll refer to from now on in the next lessons, is the refresh token. So this you must make sure that you understand how these 4 grant types work, and they will be the ones you will use again, no matter which is your implementation of the authorization server, no matter if you are using Keycloak, Okta, or your custom implementation or something else, you will use one of these 4 most probably. So this is why I wanted to spend this hour discussing them in detail, putting them on sequence diagrams so that you clearly know the flow and understand how it works. And now theoretically you know how to use them, and you should be able to use them precisely in any implementation. The last one we discuss is the refresh token. And the refresh token, which we enable usually together with another grant type, like for example, I can say I want password, but I want also refresh token. And here like this. And by the way, I did only for making the example simpler, I did only add the one grant type, so one flow per client, but you could actually say I want both the password and the authorization code for the same client. So this is possible, like I'm doing here now. I'm adding the password and the refresh token, but the refresh token anyway, it makes sense only with another grant type. So that's I will show you now what this is and what it changed by only adding here the refresh token grant type. Or here you will see that we will get one more token into the response. So you will always add the refresh token grant type together with one other grant type like this. So let's see what happens in this case and what's basically the refresh token. I did restart my application, and then I will go to the first tab in my Postman where I have requested an access token via the password grant type, and we will see how the response changed because I've added here this refresh token. So yeah, going back, you will basically see, I could have done this with any of the grant types and the change will be the same. I choose the password grant type just because it's the easiest and I have only to click the button. I don't have to get an authorization code again. The response changed slightly. Now with one more row here, you see that in the response, we also now have a value called the refresh token. This wasn't there in the previous code. So before adding the refresh token grant type, we didn't have that value here in the response. What is this value and how can we use it? Well, we use this value to obtain a new access token without needing to make the user authenticate again. So in case we use this refresh token, by the way, in case of grant types that deal with users, so not the client credentials, but in case of the authorization code or the password or the implicit, but again the implicit grant type, we don't use it anymore because we want to have a possibility to obtain a new access token without forcing the user to authenticate again. So without, in case of the password grant type, without needing to somehow store the credentials of the user and obtaining a new token, or somehow in case of the authorization code, redirect back to a login and force the user to log in again. So we want a solution to avoid this need of re-authenticating, and the refresh token does that. The refresh token allows us to get a new token without forcing the user to re-authenticate, without forcing the user to re-enter their credentials somewhere. So instead of that, we just call again the token endpoint and we provide this value, and the token endpoint will get back us a new access token. And again, we need that because this access token, it's not forever. It expires, and you can see it even has, I didn't define it, I can customize it, and you will learn how to customize this in your authorization server, or if you use a tool like Okta or Keycloak, it's even easier because you just have to configure it somewhere. But the token expires after a while, and that while, how much time, how much time does it live, that really matters on your application, on your scenario, but usually you don't make it a very big lifespan. And then you need to have a way to get a new access token without the user having to re-authenticate. So let's see, will you address tips to the alter the expires in value? Oh, it's just what I was discussing. Probably I'm a little bit delayed. My video is a little bit delayed. So I could not determine how to do this programmatically. Yes, you can actually do that programmatically, and I will show you how to deal with tokens. Basically, it's one of the next subjects that we will dig into, is how to use a token store. And the token store, you will see, is the component in the Spring Security architecture that deals with the tokens. So the token store is basically the way to customize your tokens. And when we'll discuss the token store, that's the point where I will show you which are the implementations of token stores, and we'll also discuss about some other token implementations like the JWT implementation, and we'll discuss everything about how to customize that. But yes, the idea is the expires in, of course, how to customize that in your custom implementation, because if we refer to Keycloak or Okta, that's each tool has its own interface, and in the interface then you can customize it somehow, or in some situations you even have a command line interface and you have commands to do that. But of course we can't take all the possible tools to use and discuss that. But I will show you how can you deal with that if you do your own customized authorization server. So again, the refresh token should now be possible to use to get a new token when this one expires, so that the client doesn't need to force the user to re-authenticate. Let's see how can we do something like this. So it should be again something very similar, and token, and then I have to provide a valid value of the refresh token, and that would be a post, and then I have to authorize with client 1, I guess was the one I've used. Okay, bad credentials for some reason. Probably my token is not valid, I'm not sure. Oh, password, no, it's not password, sorry, it's the refresh token. I have to provide, I copy paste it. That's why you should never use copy paste programming. And I still have something here. Anyways, I'm not sure what I'm now doing wrong, but you use the token, the access token to re-authenticate. So it should have been something like this call, and then get a new pair of access token and refresh token. So that's how you use it. Basically that's it on the four grant types, on the four main grant types. And with that being said, theoretically we've finished what I wanted to discuss with you today, and it's pretty cool because we have discussed basically of all the important grant types. And now the next thing we'll discuss is how to customize your tokens, because you see, I will very fast show it to you because I have a few minutes left, but I can't go into a lot of details now. Next lesson probably will do that, not probably, for sure we'll do that. But again, going back to our tokens, you see we only have some UUIDs, and again, OAuth 2, it doesn't force you use any kind of implementation of token. You can even have a plain string if you want. We don't have implemented token stores for plain strings, but UUID anyway, it's a plain string, so it can be considered only a very simple implementation, the simplest implementation. What I wanted to say is that you can actually create whatever your implementation is. You can create a token store of your own. You'll usually not do that because the token stores provided by Spring Security are more than enough to work with anything. So if you would like to, for example, customize your token, and again in details we'll do that in the next lesson, you just have to create a token store. And for example, if I would like to use a token store from Spring Security, like for example if I would like to use a JWT, you will see the simplest way actually to use a JWT is just to use the JWT token store, which is again configurable. It's a little bit more complex because you need also a converter in case of the JWT token store. So I will now very fast create a converter. I won't explain what a converter is now because I will do that in the next lesson. But if I want to show you completely that it works and that you get a new token, I need to create this converter as well. New, and I will simply create a plain object I call here. Nope. Converter. And then what I need to do is actually make them beans in the context and use the proper Java syntax, of course. And then you just need to set your token store here with the token store method, the way you've set up your authorization manager. And in case it's a JWT, you also need to store to set that converter. So it's not all the cases, but with JWT it's also a converter. Again, I don't explain this because now I'm just trying to prove you how easy it is to simply change your token. Yeah, but in the next lesson we discuss about the token implementation. So you will, and of course we will have plenty of things to discuss about JWT, which is not an easy subject. But I'm just trying to prove you how easy here you can use an implementation of token store to change your token store, especially. And make it change it from a normal, for example, UUID, which is the opaque token Spring Security offers by default as an implementation, to JWT. So now I'm going back, and can you see it is the same thing. I'm just pressing the send button again. And boom, everything changed. This is a JWT token. So I only added a couple of methods for that. Pretty easy from the implementation point of view to do that. And as we'll discuss, these implementations of token store, which is a contract, this is an interface. This is the interface that Spring Security uses to manage tokens. And you have a few implementations. The in-memory token store is what you used until now, and where by default you had UUIDs as tokens. JWT token store is what I've used now to prove you how easy it is to change the implementation of a token store. And then you have some others we'll discuss as well. The JDBC token store we'll discuss when dealing with blackboarding and storing tokens in the database. The JW key token store is an implementation where you can use a key and a certificates endpoint on the authorization server. That's pretty useful for key rotations. Redis token store is in case you would use an in-memory Redis database for your application. We'll discuss these token stores, and you will see some of them are really important and really used in real world examples. So stay tuned, because that's basically what we are doing next. And then if you are, maybe I can do something like this in my last 3 minutes of this session. Token store. And some of the things that you want to customize, you can customize directly through the token store. So for example, now these are actually the methods that are called by the framework to read your authentication from the token store, read the access token, find the client ID, and so on. And some of the things that you need to do, you can change also through the configuration itself or through the converter itself, like in this case here. See, in case of, for example, a JWT, I didn't do this now, but you need to either set a key pair for signing the token, or a set signing key if you use symmetric keys, for example, and so on and so forth. So there are plenty of things that, again, we need to discuss about the tokens, and that we will discuss. This was only to make you aware what comes next. Again, just to give you a taste of what's the next thing we'll discuss about. And then, of course, going back to my diagram, considering we know all the grant types now that we'll use, and when we finish with the tokens as well and discussing the tokens, which is again a very important subject, we'll go to the resource server and we'll discuss how can the resource server prove that an access token is a valid one, aka that was really issued by this authorization server and it's not fake somehow. And that's again where we'll have to discuss plenty of details, because there are multiple ways you can do that, and you would choose to do this depending on, of course, the design of your system. Okay, and with this I finished what I wanted at least to tell you today. Thank you very much for watching. Thank you very much for your questions, and stay tuned, because we still have a lot of things to discuss about OAuth 2, and not only. And not to say that when we finish with the OAuth 2, we still have to discuss about the authorization, reactive applications and Spring Security, testing your security implementations, and even deploying them. But about the deploying, I'm still thinking, because maybe I need to first create a stream about Kubernetes. That's it. Thank you very much. Thank you also, and have a great time for study. Till next week.